Implications of multilayer protocols. Welcome to this lesson on the implications of multilayer protocols. Modern networks rely on protocols that operate across multiple layers of the OSI and TCP/IP models. While multilayer protocols improve efficiency and interoperability, they also introduce security challenges. Attackers can exploit vulnerabilities at different layers to bypass defenses, disrupt services, or steal sensitive information. In this lesson, we will explore how multilayer protocols work, their security implications, and best practices for securing network communication. Let's get started. A multilayer protocol is a network protocol that operates across multiple layers of the OSI or TCP/IP models. Instead of functioning strictly at one layer, these protocols perform different functions at different levels, making communication more efficient. For example, transport layer security, or TLS, works at both the transport and application layers. It encrypts web traffic at the application layer while securing the transport of that data at the transport layer. This flexibility allows TLS to protect many types of communication, from web browsing to email and VoIP calls. But multilayer protocols also create security challenges. Attackers can exploit weaknesses at different layers to manipulate data flows, inject malicious traffic, or conduct man-in-the-middle attacks. That's why understanding these protocols is essential for securing modern networks. Here's how to manage the security of multilayer protocols. Implement network segmentation to isolate critical systems and reduce attack surfaces. Use intrusion detection systems, IDS, and intrusion prevention systems, IPS, to monitor and block suspicious traffic. Regularly patch and update network devices to fix vulnerabilities in protocol implementations. Multilayer protocols offer several advantages in network communication. They allow for more flexible and scalable designs, improve interoperability between different systems, and enhance performance. One major benefit is redundancy. If a security control fails at one layer, another layer can still provide protection. For example, even if an attacker bypasses encryption at the application layer, a VPN using IPsec at the network layer can still secure the traffic. Multilayer protocols also enable cross-layer optimization. This means that performance can be improved by coordinating actions across different layers. For instance, a web browser can adjust its data requests based on network congestion detected at the transport layer, ensuring a smoother user experience. However, these benefits come with trade-offs. More complexity means more potential attack vectors, and improperly configured security controls can lead to gaps that attackers exploit. Here's how to maximize the benefits of multilayer protocols while minimizing risks. Use encryption at multiple layers to ensure data remains secure. Monitor traffic patterns to detect anomalies that may indicate attacks. Enforce access controls and authentication mechanisms at each layer. While multilayer protocols improve communication efficiency, they also introduce several security risks. Attackers can exploit vulnerabilities at different layers to intercept, modify, or disrupt network traffic. One common attack is protocol tunneling. This happens when attackers encapsulate malicious traffic inside legitimate network protocols to bypass security controls. For example, an attacker could hide malware inside DNS requests, allowing it to pass through firewalls unnoticed. Another risk is cross-layer attacks. Since multilayer protocols operate at multiple levels, an attacker can target weaknesses at one layer to compromise another. For instance, an attacker might exploit a flaw in the transport layer to gain control over an application layer service. Man-in-the-middle MITM attacks are also a major concern. Attackers can intercept and modify traffic as it moves between layers, stealing sensitive data or injecting malicious commands. This is why using secure protocols like TLS and IPsec is essential to prevent interception. Here's how to mitigate the risks associated with multilayer protocols. Implement Deep Packet Inspection (DPI) to detect hidden malicious traffic. Use mutual authentication to ensure data is exchanged between trusted parties. Configure firewalls and intrusion detection systems to block unusual traffic patterns. Let's look at a real-world example of how multilayer protocols impact security. Imagine a company that uses voice over IP, VoIP, for internal communications. VoIP traffic travels across multiple layers: SIP at the application layer, RTP at the transport layer, and IP at the network layer. Each of these protocols plays a role in delivering voice communication efficiently. However, if security isn't properly configured, attackers could exploit this setup. A hacker might launch a denial-of-service DOS attack against the VoIP server by flooding it with SIP requests, overwhelming the system and disrupting calls. Meanwhile, an eavesdropper could intercept RTP packets to listen in on conversations. To protect against these threats, the company can implement end-to-end encryption for VoIP traffic, enforce strong authentication for VoIP users, and use intrusion prevention systems to detect and block suspicious activity. This example shows why understanding multi-layer protocols is critical for securing modern networks. By applying security at every layer, organizations can prevent attacks and ensure reliable communication. Here's how to secure multi-layer communications. Use VoIP encryption (TLS) to protect voice data. Deploy intrusion prevention systems (IPS) to detect VoIP-based attacks. Enforce strong authentication (FA) for VoIP access. Now let's summarize what we've learned about the implications of multilayer protocols. Multilayer protocols improve efficiency, redundancy, and interoperability in networks. They also introduce security risks such as protocol tunneling, cross-layer attacks, and MITM threats. Attackers can exploit vulnerabilities at different layers to bypass security controls or disrupt communication. Organizations should apply encryption, access controls, and network monitoring across multiple layers to prevent attacks. By understanding how multi-layer protocols work and securing them properly, security professionals can design more resilient and secure network architectures. This concludes our module on the implications of multi-layer protocols.